Okay, I've got half a kilogram of propane initially here, undergoes a process to here, being compressed, and a heat transfer occurs at 20 degrees through the wall. Network is this. Kinetic potential energy effects ignored. It says here determine whether it's possible for the work measurement to be correct. And really what we're going for here is, hey, is sigma negative? If sigma's negative, that's impossible to happen, right? So my second law equation for a closed system is S2 minus S1 equals the integral of Q over T plus sigma. Now, I know my states, right? I've got pressure and temperature beginning and after, so I can look up S1 and S2, okay? I need to figure out the heat transfer, okay, so that I can apply it into this equation as well. I know the work. I also know two states. Therefore, I can use the first law equation, which is basically, again, delta U equals Q minus W. So I'll first start by finding Q. Then using Q, I can calculate S. Now, before I do that, let me go through and figure out basically U1, S1, U2, and S2. Look up these states. Now, this is propane. First state is 4 bar, 30 degrees Celsius. So I go to table A18 in the book. Again, this is propane. Okay, I go to 4 bars, which is right there. And again, I go down to 30 degrees, which is right here. My U value is 472.2, and my S value is 1.969. Now I go to 14 bar and 100 degrees. That is what state 2 is. So 14 bars right here, 100 degrees is right there. My U value is 577.9, and my S value is 2.092. So let me go ahead and jot these down. Those are my states that I'm at. Okay, so again, U1 is 472.2, S1 is 1.969, U2 is 577.9, and S2 is 2.092. Okay, now I go over here. I plug in 0.5 kilograms times U2 minus U1, so that's going to be 577.9 minus 472.2 equals Q, which is what I'm looking for, minus the negative 72.5 kilojoules. That is my work. From this, I can calculate then that the heat transfer is actually negative 19.65. That would be kilojoules. Now that I have that, I can use my second law equation, where I take my mass, 0.5, times the change in entropy, which is going to be 2.09, minus 1.969. Set that equal to Q over T, which is going to be, again, we just calculated Q, negative 19.65. T, again, it says up here, is the heat transfer occurs at 20 degrees Celsius, which is actually 293 degrees Kelvin plus sigma. From this, I learned that sigma is 129 kilojoules per Kelvin. Again, that value not super important, other than the fact that it is positive. Sigma is greater than 0, so W is correct. Okay, so again, set your states. Look up U's and S's, and then from first law I can calculate Q. Once I have Q, I can use my second law to calculate sigma. Sigma is greater than 0, so it is absolutely a real system.